Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, and salam sejahtera to all of you. Okay, so this is a pre-recorded lecture concerning chapter 6 about hydropower. Okay, so this will be one of the last renewable energy technologies that I'm going to introduce to you guys. Okay, so hydropower. So basically, hydropower. I think all of you know hydro means anything that relates energy power related to water. Water. Okay, so let's start. Okay, so some introduction to hydroelectric power. Okay, before this, I think Ajin, is it? Was it? Some of you have already presented some theoretical and application of this hydroelectric power. So maybe some of the general information you already know. So here is introduction. I'm going to still introduce to you that the hydroelectric power is generated through the gravitational force of flowing or falling water. So basically, the main characteristic, the key point regarding this hydroelectric power is water, of course, the source of the energy for this hydroelectric power. Okay, water. And the other one is how the form of what is the form of the energy, of that energy, the water. So the form of the energy here is the gravitational force, which is related to potential energy. Remember, first law of thermodynamics, energy balance. We know that energy cannot be created nor destroyed. So thus energy can only transform from one form, one types to another form. Okay, so how this basically how this hydroelectric power works is that it generates started with the gravitational force. Okay, when there is a gravitational force uh, at um at some altitude level, okay, flowing down, okay, falling, the water falling, so that cause this gravitational force cause potential energy store, okay, in the water to be transformed into another form where we can produce power. Okay, so the energy store, the potential energy store in the water at a higher level, okay, due to this gravitational force. So we have gravitational force. Due to this gravitational force, we have energy stored in the water, which is what we call potential energy. So this form of energy, potential energy, will be transformed to another form of energy, okay, which is power created, mechanical power, electrical power created, okay, or kinetic energy, okay. So here, most widely used renewable resource accounting for 60% of global energy. So the hydroelectric power is somehow one of the most used, okay, alongside with the solar, biomass, okay, most widely used renewable energy resource. It is renewable because water, the source, the main source, which is water, is always available, okay, in this earth. Okay, so this hydroelectric power resource accounting for about around 60% of global energy. Okay, so around 150 countries have used and produced this hydropower. The Asia Pacific region produced 32% of global hydropower. Okay, so Asia Pacific mainly China, okay, and all that on the east side. Okay, China is the largest producer of hydropower. Once a hydroelectric project is completed, it operates with virtually no waste, and its CO2, carbon dioxide production, is significantly lower than the production of energy using fossil fuels. So the advantage, some of the advantage of using this hydroelectric power is, of course, it has no waste. Okay, basically nearly no waste. Okay, zero waste and lower carbon dioxide production. Kind of like other renewable energy source as well. Okay. So how does it work? Okay, so practically is the hydroelectric was starting from water is needed to run a hydroelectric unit. Okay, so we use, as I've mentioned just now, we use this this potential energy stored in the water due to the gravitational force is needed. Okay, the energy stored in the water is needed to run a hydroelectric unit. Okay, to produce electric power. Okay, so the force of the water, the force, gravitational force, that gravitational force being released through the dam spins the blades of a turbine. Okay, through the dam ni bahasa Melayu empangan. Okay, ada empangan spins the blades of a turbine. Okay, so the force, the gravitational force, and the energy stored in the water, okay, is going to spin the blades of a turbine. Okay, due to this force, it as how to say it gives energy to the turbine, the blade of the turbine to turn, to rotates. Okay, so it is like wind energy. Okay, the wind, except that the wind energy, the source is the air, wind. Okay, air, wind. So the wind will the force, the kinetic energy stored inside the wind. Okay, the wind speed, okay, will how to say akan menyebabkan, will cause the blade of the turbine to rotate. So the same as this here, the force of the water, the energy inside within the water, okay, due to the gravitational force will cause the blades to spin, the blades of the turbine to spin, so generate power. When the blades of the turbine spins and the turbine is connected to a generator, so this transformation from potential energy of the water due to the gravitational force to the kinetic energy, okay, the blade spin, okay, this energy within the turbine, so the turbine connected to a generator, so the generator will produce electrical power. So whenever the water is done going through the turbine, the water flows into the river again. Okay, so when it is settled, the water has settled, goes through the turbine. Okay, the turbine spins, and the blade of the turbine spins, and the turbine is connected to the generator, so produce electricity. Thus, the rest of the water is will flow again into the river, and thus the cycle will continues again. Okay, so that's generally how the hydropower works. Okay, so this is the kind of like a schematic, not schematic diagram, but the how we present, okay, the as an example of hydroelectric dam, empangan hydroelectric, electric hydro, okay, electric hydro water lah. Okay, so from the reservoir at a higher level, okay, empangan, a dam, at a higher level altitude. Okay, so the water will flow and will cause the turbine to spin. Okay, the turbine to spin. The blade of the turbine will spin, and the turbine is connected to generator. Thus, it will produce power. So the rest of the water, after went through the turbine, it will continue flowing to the river, and thus the cycle continue. Okay, so this is the video on how it works. Okay, maybe we can watch it, you can watch it later on. Okay. Okay, some of the advantage of using this hydroelectric hydroelectric power. Okay, first of all, no pollutants. Okay, so we no waste, no pollutants, no greenhouse gases. less production of carbon dioxide, saving natural resource, a renewable source of energy, dams as a water reservoir, economical advantage, constant source of energy, controllable source of energy. Sorry. Okay, constant source of energy. Since the water is always available, so it is always renewable. Okay, so compare here. If you look at the diagram here, if you compare the average power production expense per kilowatt hour of compare it with fossil fuel, nuclear, gas turbine. Okay, so hydroelectrics basically use fuels less, okay, cents per kilowatt hour, okay, due to the maintenance and operation. Okay, it doesn't need any fuel. Okay. However, we still has disadvantage. We still have disadvantage due to the disturbance of habitat. It might disturbs the habitat in the water. Okay, all the organism in the water. Installation cost is still it's like a big power plant. So economically we need higher budget cost, limited use. Okay, divert natural waterway. Okay, so basically the water should run freely directly to the river, for example. But instead, when we use this hydroelectric power, the water needs to uh, goes through the turbine first. Okay, fish killing, the same as this disturbance of habitat just now, breaking of dams, deposition of silt. Okay, okay. Silt ni macam kelodak lah, macam selut kan. So dia akan menyebabkan selut lah, macam sekarang banjir kan, banyak sangat selut. Okay. So, some of the examples of worldwide where exists this hydroelectric. Okay, first of all, first one is Three Gorge Dams. I have Three Gorge Dams. This one, okay, the picture of a Three Gorge Dam in China. Okay, so Three Gorge Dam located in People's Republic of China, largest dam in the world, spans the Yangtze River with all of its 32 generator. It can produce 22,500 megawatts. So it's actually giga? Okay, 22.5 gigawatts. Okay, cause problems because it's flooded over 1,300 archaeological sites and 1.3 million people had to be relocated. Okay, so that is the disadvantage of this dam. Okay, this hydroelectric power plant. Okay, cause flood. Okay. Another one is between Brazil and Paraguay. So in South America, this one, okay, Itaipu Dam. Okay, empangan ni, nampak tak? Dia besar, so dia memang costly lah. Walaupun macam water tu always available, a renewable source. But to produce a hydroelectric power plant ni, dia perlukan bajet yang besar lah dan keluasan yang sangat besar. Dan macam tadi, dia akan antara disadvantage dia menyebabkan mungkin certain perumahan kat situ, penempatan kat situ kena pindah kan. So that is disadvantage even though water tu is always available. So Itaipu Dam built by both Brazil and Paraguay on the Paraná River. So dia macam dekat Brazil dengan Paraguay lah, sempadan tu kan, dekat frontier. Each country owns half of the 14,000 megawatt output that the dam produce, so 14 gigawatt, second largest dam in the world. So yang China tadi tu, the China it's higher lah, 22.5 megawatt, 22.5 gigawatt. Okay. Okay. Sorry. Tak saya tekan ni. Okay. Oh, dia ke situ pula. Okay. Okay, so some of terminology or definition that you need to know concerning this hydropower. First one is head. So what does it mean when we call head? What is head? Okay, here head, not actually kepala lah, walaupun dia macam melambangkan something yang dekat atas, tapi head kat sini bukan kepala lah. Okay, so head, what is it? Head, water must fall from a higher elevation to a lower one to release its stored energy. So like I've mentioned just now, this hydroelectric power really depends on the gravitational force. So a higher level of altitude means higher store energy, higher potential energy. Okay, so higher potential energy, higher tinggi dia lagi tinggi, so banyak lagi lah store energy dia. So water must fall from a higher elevation to a lower one. The difference between these elevations, so daripada higher to the lower until dia jatuh tu, the water levels in the forebed and the tailbed is called head. Okay, so basically this hydroelectric power theoretically it use the same principle as in fluid mechanic, especially Bernoulli principle. Okay, you remember in fluid mechanic we have learned Bernoulli principle kan. So dalam Bernoulli principle tu dia ada adalah kita belajar tentang head loss, energy loss to the head, apa semua, dia ada istilah the same terminology juga. So basically the Bernoulli principle is applied here in this hydroelectric power. Okay, dams three categories. So another one we have dams, empangan. So there are three categories of dams for this hydropower. Okay, so the 800 or more feet is what we call high head, and then medium head around 100 to 800, and last one low head less than 100 feet. Okay, so how do we calculate the power produced by this hydroelectric? Is that the power is the product of the head times flow. Okay, so flow is in normally in meter cube per second. Okay, and head is the meter lah. Okay, ketinggian dia tu. Okay, so this is example classification of hydro plants based on head. So you can see in those figures here, we have the high 66 feet and higher. Okay, empangan yang besar, lepas tu lower dam, and ultra low. Okay, low dam. Okay, so dia punya apa tu ketinggian elevation itu, can see this is the elevation tinggi ya. Okay. Okay, types of hydroelectric installation. So different head, different elevation of head, so have different types of installation. Okay, so different head ketinggian elevation berbeza, so dia punya installation pun berbeza lah. Okay, so the first one is low head, so that is kind of like direct from the river to the turbine. And continues flowing down to the river, and medium head we need to have kind of like a penstock here to flow the water from the reservoir, and the high reservoir one is like this. Okay, so the installation is quite different depending on the level of the elevation of the dam. Okay, so just now is the level of elevation. This one is the level of scale of the hydro of the power produced. Okay, so we have from large to until pico. Okay, so we seldom hear this pico. So large hydro can produce around 100 megawatt into a large electricity grid. So just now the two example previously apa tu? And in China and in Paraguay and Brazil, South America. So those are example of large hydro, of course. So medium hydro produce around 50 to 100 megawatt, small hydro 1 to 15 megawatt, and then mini hydro, micro hydro, and pico hydro. Okay, so depending on the application. Okay. Okay, so this is example. Hydropower is used in two ways: direct or electrical generation. Okay, means that one way direct means the energy, okay, produced by the water, from the water, stored by from the water, is being directly used for application, for any application. Electrical generation means that the energy due to the water, hydropower, is going to run through the turbine, goes through the turbine, and the turbine will be connected to a generator, and then the generator will produce electricity. Okay, so this is some of the direct use of hydro energy, basically in rural area. For textile manufacturing, kain-kain kan, untuk manufacturing kita boleh guna hydro energy ni. Okay, yeah. And then for grease mills kan, grease pasir untuk apa tu, uh, uh, kilang buat pasir lah, manufacture pasir, and then lepas tu kita ada kilang papan, sawmills pun boleh guna direct hydroelectric power. Okay, and then we also have irrigation, sistem pengairan. Okay, sistem pengairan untuk penyaluran air, basically in the rural areas lah, so they can use this direct use of hydro energy, okay, to supply power for this to manufacture those textile, grease, pasir, sawmills, kilang papan semua. Okay, and types of hydroelectrical generation. Okay, ini pula kalau hydroelectric power using hydroelectric generation. Okay, first of all is the impoundment, macam sistem penahanan air tu. Pump storage capacity, runoff river, diversion. So basically yang besar-besar sikit lah. Okay, yang besar-besar. So these are the example. Impoundment generating facility to like high head kan, empangan tu high elevation. Pump store capacity kat Wales, kat United Kingdom, maybe this one is medium head. Diversion facility, ni pun agak besar kat US. Okay. Okay, so worldwide hydroelectricity output has increased. Okay, so this is the data from in 2011. Okay, so worldwide hydroelectricity output has increased around 2,500 billion kilowatt hour, 60% of all energy production, as I've mentioned earlier. Okay, so the output, okay, the production of this hydroelectricity has increased since 1965, means since around 50 years ago. Okay. Okay, so which countries really relies on this hydropower? So basically first one is China, US, Brazil, Canada. Okay, so some of the European country, Russia, Asia Pacific, Japan, okay, India, Norway, and France. Okay, so those are the top hydropower generation countries with their installed capacity. Okay, as of 2014. Okay, this one the latest. That I have found. Okay, maybe there are some more latest. Okay, so around watt hour. Okay, this one. Okay, so basically actually what I wanted to focus is on the hydropower. Okay, due to water dekat empangan sungai apa semua tu kan, but I include a bit since the source is the same, which is water, so I include here other potential new source of hydroelectricity, which is tidal and wave. Okay, but actually tides and wave dia jatuh di bawah ocean energy sebenarnya. Okay, ocean energy kan, not basically it still can be considered as a hydropower sebab hydro kan, water juga source dia, tapi dia punya macam mechanism dia lain sikit. Okay, so basically kalau kita tengok biasanya tides dengan wave ni dia termasuk bawah ocean energy, not directly bawah hydropower lah. But it's okay, I just introduce a bit about this tides and wave. So tides ni macam air pasang surut, pasang surut air kan, and wave pula ombak lah. Okay. Okay, so tide power. So pasang surut air ni boleh generate renewable energy source juga. So based on daily movement of water in oceans. Okay, so tide dengan wave ni datang kat mana, daripada ocean. Itu yang lainnya. Dia walaupun dia still water, air, tapi tak dengan wave ni biasanya dekat ocean lah, dekat laut. Tadi kalau macam hydropower yang tadi kita tengok tu basically dekat sungai, kat empangan kan. Okay. So based on daily movement of water in ocean, so kejadian pasang surut air tu boleh menghasilkan power energy lah. Okay, most effective in areas with pronounced tides. Okay, yang banyak pasal surut air ni include tidal stream systems, kinetic energy of flow, barrage, head energy of surface difference. Okay, so dia punya macam mana macam mana energy power ni boleh terhasil daripada tide ni, pasang surut air ni, due to the kinetic energy. Okay, flow of the water tu ada kinetic, pergerakan air tu ada speed dia. So ada velocity dia, so dia ada kinetic energy lah. So stream flow tu dia ada kinetic energy. Daripada kinetic energy ni lah yang hasilkan power kan, kinetic energy of the stream flow tu. Another one is the barrage. Okay, from the barrage ni macam rentetan. Macam mana cakap heat energy. So bila cakap heat energy je macam tadi juga, heat energy means potential energy. Dia ada ketinggian dan surface permukaan tu ada different elevation, different altitude, different surface tu. Heat energy ataupun potential energy lah. Bila ada different elevation of the surface tu, so dia ada some sort of potential energy dalam tu. So potential energy ni boleh hasilkan power lah daripada tide ni. Okay, so tide power includes two types of energy mechanism, okay, a source. Okay, dia punca dia datang daripada dua. Satu daripada tidal stream due to the kinetic energy, satu lagi daripada barrage due to the heat energy ataupun potential energy, ketinggian elevation yang berbeza. Okay, so tidal stream system. So this is example of a system tidal stream yang due to the kinetic energy tu. Dominant technology is shrouded turbine. Prototypes have been tested in England, Australia and Italy, outputs up to 1.2 megawatt are noted. Okay, so macam 1.2 megawatt tak adalah banyak sangat berbanding dengan tadi tu kan. Any barrage system depend upon impoundments built along coastlines. Sistem penahanan tu yang dekat coastline developed in Canada, Russia and France. Basically kat negara lain atas tu lah kan. Okay. Largest generate 240 megawatt, so lebih besar, limited by geographic environmental considerations. Okay. And then we have wave, okay, ombak. Power, hydropower hydroelectric due to the wave power. So based on up and down motion of sea surface, so motion pergerakan, kinetic energy can be captured using device that convert motion to electricity. Okay, once we have device yang boleh convert kinetic energy ni to electricity, macam turbine tadi, turbine dia convert kinetic energy to electricity kan, bila dia connected to the generator, create more electricity than tidal, so boleh jadi dia lagi dapat banyak lagi. Recently developed a system include around 2 to 3 megawatt. Okay. Challenge include low speed, corrosion, wind damage. Okay, so kalau speed ombak tu tak kuat, macam wind speed, tak banyak lah kan. Kinetic energy boleh hasilkan. Okay, so this is some of the current situation in Malaysia. Okay, so from this paper, journal, a state-of-the-art review of hydropower in Malaysia as renewable energy, current status and future prospects from journal Energy Strategy Reviews Journal in 2019. So you can look at the journal, you can search this journal. So basically share of the install, if you look at the pie chart here, share of the installed and available electricity generation capacity as of 31st December 2014 in Malaysia. Okay, so basically install electricity generation, our country, majority is still from natural gas. Okay, but we can look here, hydropower is third. Okay, second is coal, but hydropower is third, around 15.9%, which is 16% just now. Okay. And then available electricity generation. Okay. Still natural gas is the majority, and then we have coal and hydro 13.9% or 14% as the third source of available electricity. Okay. So hydropower was the leading source of renewable energy. So among all the renewable energy, so hydropower leads lah. Okay. Was the leading source of renewable energy among all renewable source, providing about 83.24% of all electricity generated by renewable sources and approximately 15.9% of the country's total electricity production. Okay, so kalau compare dengan other renewable energy source, hydropower yang leads lah, sebab natural gas dengan coal is not a renewable energy source. Okay, hydropower potential is available in almost all of Malaysia states, although the high potential sites are Perak, Pahang, Sarawak and Sabah states. So those are the states that has sungai banyak kan, besar kan. As a result, Malaysia receive an annual average rainfall of more than 2,500 mm due mainly to the southwest and northeast monsoon. So monsoon apa ni? Southwest monsoon southwest. Monsoon apa? Barat daya. Okay. And northeast monsoon timur laut. Okay. Okay, a state of the art review. Continuation from the same article. So this is a hydropower project in Sarawak between 2008 and 2020 with the total capacity around 7,000 megawatts, so 7 gigawatt. Okay, quite not bad. Okay, compared to the highest just now the largest hydropower in the world is China 22.5 gigawatt just now kan. 2.5, and the South America one, Paraguay and Brazil is around 16 something, right? 16 gigawatt. So us, we have built this hydropower in Sarawak with a total capacity of 7 gigawatt. Kan? So not bad lah, 7 gigawatt compared to the largest in the world, 22.5 gigawatt. Okay lah kan. But us is the sum total lah, total campur semua ni. Dia bukan satu projek je lah kan. So dia campur semua. Kalau macam China tadi satu empangan tu dah dapat 32.5 gigawatt. Okay, so dia ada campur-campur ni lah, banyak-banyak ni kan. So dia kecil-kecil, medium class, so campur jadi 7,000, so not bad lah kan kat sini. Okay, a state of the art review of hydropower. Okay, sama lagi. Assessment of micro hydropower in Malaysia. So these are the number of for micro hydropower. So micro hydropower just now, micro around if micro the production around micro 5 kilowatt up to 100 kilowatt. So tak adalah banyak sangat, but it's okay. Micro hydropower. Okay, micro hydropower. Assessment of micro hydropower in Malaysia, number of sites, so ada 12, so banyak total around 150 lah in Malaysia. So untuk micro hydropower kita dah ada quite banyak juga, cuma yang the bigger one kan, yang belum banyak lagi lah kan sangat. So yang micro hydropower ada banyak dah ni, around 149. So with total estimated power 38,641, which is around 28 megawatt. Okay. So advantage of a small hydropower, essentially small hydropower, utilization of small water resource. So even though we have a small water resource, we still can create hydropower lah, electricity. Less social effect, less environmental effect. Okay, barriers towards small hydropower development. Okay, apa dia punya disadvantage ataupun not actually disadvantage, but halang-halangan dia. Lack of sufficient funding. So of course always funding, fund. Okay, like less private sector participation. Okay, kena invite lagi banyak lah NGO dan ini private sector untuk terlibat. Lack of technical facilities, less income of rural people. Okay, limited awareness. Okay, sebab banyak majority this water source, sungai empangan ni dekat rural kan, dia perlukan duit yang banyak lah, dan that awareness to the rural people lah, yang kata macam dia orang boleh gunakan water ni as their source of energy. Tak perlu pergi jauh-jauh kan gitu. Okay. Okay, so I have finished. Introduced to you about this hydropower. So I just have this one example exercise. Okay, so we just going to look at this one. Okay, so it's just so that you can understand better how does this works. Okay, wait I'm going to create whiteboard. Okay, so this is the link for the whiteboard. You can try to go and okay. Sekejap, sebelum tu. Okay, we read first the instruction. Okay, the water in a large water dam is to be used to generate electricity by the installation of a hydraulic turbine. So we use turbine. The elevation difference between the free surface upstream and downstream of the dam is 320 meters. So dia punya elevation tu 322 meter. Water is to be supplied to the turbine at the rate of 8,000 liter per second. Okay, to flow rate dia, the turbine efficiency is 93%. Based on the net head, and the generator efficiency is 96%. Okay, turbine tu dia connected to the generator. The total irreversible head loss, major loss and minor loss, dia ada loss. Okay, in the piping system including the penstock is estimated to be 7.5 meters. So since dia tinggi, agak tinggi, medium or to a high level of dam, so dia kena ada penstock ni lah. So ada piping, penstock ni, piping ni ada loss lah. Okay. Okay. So head loss dia 7.5 meter. Determine the overall efficiency of this hydroelectric plant, the electric power produced, and the turbine shaft power. So there are three things that we need to search for. Okay, so we use density of water 1,000 kilogram cube per meter or 1 kilogram per liter. Okay. So let's look at this example. Okay, here. So first, we want to calculate overall efficiency of the plant. Okay, so in order to calculate the overall efficiency of the plant, okay, so what we have here, we are given with the turbine efficiency, generator efficiency, okay, turbine efficiency, generator efficiency, and we want to calculate the overall efficiency. Okay, so the other thing that we need to macam sum up, total up the overall efficiency. So overall efficiency normally, okay, overall efficiency is the turbine efficiency. Normally for efficiency we multiply lah untuk tahu dia macam sum kan. Turbine efficiency, generator efficiency, and of course the efficiency of the due to the piping pipe lah. Okay, so here we are given with the turbine efficiency and generator efficiency given, so settled. Okay, just that we don't have this efficiency of the pipe. The one that we are given here is the head loss in meter. Kita tak diberi apa efficiency dia. Kita hanya tahu head loss dia dalam meter. So kita kena carilah. We have to search for this pipe. Okay, so untuk apa nama ni, untuk tahu piping punya efficiency, okay, piping efficiency, piping efficiency. So, okay, since we are given with the head loss, kita tahu yang loss, kita tak tahu yang tak loss. Faham tak? So kita macam kena tolak, okay. Apa tadi, this is energy, energy due to mechanical loss of the piping loss tu kan, energy loss over the power maximum that can be provided through the piping lah. Okay, ni energy. Okay, I repeat again, since we are given with the loss, kita 7.5 meter tadi tu kan head loss, kita diberi maklumat tentang information tentang loss, tapi bila kita nak calculate efficiency, kita nak cari yang bukan loss lah, yang actually work lah kan, the quality kan, yang betul-betul work, bukan yang loss. Okay, so that's why dia ada satu tolak tu. Sebab kita ada information tentang loss. Kita tak ada information tentang yang how much actually works. Okay, energy that actually works. So sebab tu kita kena tolak lah untuk cari efficiency ni. Okay, so this one. Okay, so we don't have information of both of these. Okay, so we need to calculate. First we can calculate the maximum power actually stored in the dam empangan tu, daripada atas tu ke elevation tu, berapa banyak actually maximum power yang store dalam water tu lah asalnya kan. So this is, so the normal definition, this is the input, the maximum power that we have, and this is the loss that we are given lah. Okay, so the main power, okay, store energy, okay, power in the daripada empangan tu adalah the mass flow rate, okay, okay, speed tu tadi, and the gravitational force, okay, remember the energy stored in the water is due to the gravitational force, and of course the elevation, okay, ketinggian tadi tu kan, elevation of the system, dam tu kan, elevation of the dam, dam tu elevation dia berapa tadi. Okay, so we can okay, since we are given here, biasanya yang mass flow rate ni kilogram per second lah, tapi kita tak ada info tentang kilogram per second, kita ada rate tu dalam liter per second, so kita kena change lah. So tukar, kita pakai density darab dengan flow rate tadi tu liter per second, so density ni kilogram per liter kan. So GH, okay. So H ni 320 lah. G we can use 9.81 gravitational force. So total we have 25,115 kilowatt. Okay. This is the maximum power that can be produced by the hydropower tu, hydroelectric tu kan, daripada water tu. Okay, next, so this one settle. So next we need the energy, the mechanical loss due to the piping. Okay, but in terms of energy, okay, so the same method, kita sama juga, kita guna rho V dot, okay, G, and this time the H is different. Okay, H is the head loss. So sama je sebenarnya, kalau kita nak bahagi ni, kita dah boleh potong-potong dah ni, kita H dam bahagi H loss je. Okay, so the same thing. So H ni, this one is 7.5 meter. So we have 589 total head loss, power head loss. 589 kilowatt. Okay, so go back to settle this one. So go back to the efficiency of the pipe. We have 0.977. Okay, 97.7% of efficiency of the pipe. So masuk balik ke atas ni balik. So darab semua ni 97.7 multiply with generator 96% and turbine efficiency 93%. So we have 87.2%. Okay, overall efficiency of the hydropower. Okay, so basically we see here the overall efficiency of the hydroelectric power is 87%. So it's basically higher than the conventional gas turbine power plant. Kalau kita guna natural gas, guna coal kan, kita need gas turbine lah power plant. So kalau kita guna yang yang non renewable source, efficiency dia normally around 50%, 50% saja. So but here if we use hydroelectric power instead, hydroelectric power plant, we have overall efficiency estimated around 87%. So higher lah kalau kita guna hydroelectric power. Okay, that is one of the advantage. So next is what do we want to calculate? Electric power produce. So electric power produce. Okay, so electric power produce. So electric power of the plant. Okay, overall efficiency tadi. So electric power produce, electric power, berapa banyak kita dapat output kita, electric power ni output kita, and berapa banyak input. Okay, input is the stored energy at the beginning. So we have, darab je lah ini dah senang dah kan. So we have 21,900 kilowatt or 21.9 megawatt. Okay. Okay. Third one, turbine shaft power. Okay. So turbine shaft power. So turbine tadi efficiency of the turbine we know. So kita guna je. Okay. So turbine shaft power. Kita nak tahu yang ni. Yang ni yang kita nak cari shaft power ni. So okay. So shaft power. So ni turbine efficiency. So how much exactly work power given to the turbine. So power given to the turbine is actually daripada asal max tu, tolak berapa banyak loss ni tadi kan, yang ni loss tu. Ini asal, the initial store energy, potential energy. This is the loss in the piping, loss kat piping tu kan. So tolak loss, so kita dapatlah power given input to the turbine. Okay. So here kita nak shaft power tu, sebab efficiency turbine we already have is given. So we have shaft power around 22,800 kilowatt. 22,800 kilowatt. Okay, or 22.8 megawatt. Okay. Okay, so that those are the answers. Okay, so you can try on your own. Okay, so you can try look at the example of the exercise. Okay, I think that's all from me for this week class. So I'll see you guys inshallah next week. Hopefully we can do live class lah. Okay, take care everyone, stay safe. Assalamualaikum.